Hello, geometers. We have been talking about inscribed angles in circles, which an inscribed angle has its vertex on the circle, so that's a key factoid you need to make sure you're aware of. And of course, the measure of an inscribed angle is always going to be half the measure of the arc it intercepts, which is another thing that really tells you everything you need to know about inscribed angles. There are just some little facts that come out of that we looked at a little bit more specifically in our notes. But sometimes we've been doing some practice problems, but sometimes you encounter problems that aren't numerical. The practice problems we've been doing have mostly been numerical, but let's look at some algebraic ones, like for instance this problem. You are given this 6x plus 11, which seems to refer to the measure of angle LKM. So in that case, I'm going to think about where LKM is. Here's one side of LKM, and here's the other side of LKM, and which arc LKM intercepts, and that would be this arc. So the pink purplish angle is half the measure of the green arc. That's what we know by knowing, since K is the vertex of that angle and it's on the circle, it's an inscribed angle and it measures half the arc it intercepts. So another way of saying that this is half of this is that the arc is twice as big as that angle. Two different ways of saying the same thing. So if the arc is twice as big as that angle, then that means that this arc must measure 2 times 6x plus 11, otherwise known as 12x plus 22. Now, I didn't necessarily have to change the 2 times 6x plus 11 to 12x plus 22. Now, I could have waited to do that later, but I chose to go ahead and change it now. Whether we do it now or later, whenever we get an expression for this green arc, we now have algebraic expressions that go all the way around the circle. In other words, I've got an expression for this arc, it's 9x minus 2. I've got an expression for this arc, I could call it 2 times the quantity 6x plus 11 or 12x plus 22. And I've got an expression 4x plus 15 for that arc. Well, what I just did was went all the way around the circle. That's 360. So let's go ahead and use 12x plus 22. And that way we can go ahead and write our equation that we're going to solve. Because anytime you need to solve for x, that means you have to set up an equation. So you have to figure out a relationship you can turn into a mathematical sentence or an equation. So here we have decided we can say 4, I'm going to make that bigger, and that's not how. We could say 4x plus 15 from right here, plus 9x minus 12 from right here, plus 12x plus 22 from right over here, all has to add up to, what's all the way around a circle? 360. So that's the equation that I am going to solve in order to find out what x is, and then I can go back and plug that in to find out what the angles are or what the arcs are. Let me go ahead and do this one. 4 plus 9 is 13, plus 12 is 25, so I have 25x plus, and numerically I've got 15 minus 12, that's 3, plus 25, that's 25. Plus 22 is 25, equals 360. I'm coming on over here. Oh, let's see. Don't like that color. That gives me, subtracting 25 from both sides, gives me 25x equals 335. Is that right? Hopefully I didn't just mess something up. Looking back over my work, it looks good to me so far, so good. And it's just not going to work out perfectly as a whole number, which is perfectly fine, but we tend to get used to getting whole number answers or integer answers and get a little alarmed when we don't get it. And I could just leave it like this and say x is 335 over 25, but I would probably rather reduce that. Or in this case, really, I might want to change it to a decimal because I'm going to be plugging it back in to find these angle measures. And I'm pretty sure on the worksheet I've given you, your answers are going to be in decimals. So you may as well go ahead and turn that into a decimal. The main thing I wanted to show you, though, was how to set it up. That's the key thing here, because I know you know how to solve equations. So let's look at another one I could turn into an equation. First thing to notice here, and first thing to notice a lot of the time, is that you have a diameter. This is a diameter. Every time you have a diameter, you've got two sides of the circle, and each side of the circle has to add up to 180. In other words, two halves of the circle, not just sides. But a diameter divides the circle into two halves, each of which is 180 degrees. So that yellow arc I just traced over has to be 180 degrees, which means that 10x minus 4 plus 13x has to add up to 180 degrees. That's the equation I would use here. That'll allow me to solve for x, and then I can go back and plug in and find the measure of the arcs or the measure of any angles that I need to. Do notice that you have a triangle inscribed in a semicircle here, meaning you got this triangle. Well, let me change colors. This triangle right here is in half of a semicircle. So while this doesn't enter into what we're doing down here, you do need to be aware this makes this a right angle. Because every time you have a really ugly, sorry, cheapers, I can't draw straight suddenly. Every time you have an angle, an inscribed angle that goes through the endpoints of a diameter or intercepts an arc that is a semicircle, two different ways of saying the same thing, this has to be a 90-degree angle. So keep that in mind if you were trying to solve for something else besides just the value of x, or maybe arc NM or arc ML in this particular picture. Moving right along, we have this one. Now remember that every time you have a quadrilateral in a circle, the only way that can work is if opposite angles, meaning for instance x and v, these two angles, are supplementary. They add up to 180. Okay, so that's something to keep in mind. I think the easiest thing to take, let's see, there are a couple of ways we could do this because of that. I think that using that is actually not the best plan. Here's what we could do. Let me tell you what we could do to use that. I could say this angle, which is half of these two arcs, has to add up to 180 with this angle. So in other words, I could say, let me go ahead and get an expression for these two arcs, 9x plus 8 plus 14 plus 14x, then divide everything by 2, half of that, and that would stand for this angle, and then write an equation that says these two add up to 180. That's one way I could go. I don't think that's going to be the best way. I think the best way here is going to be to go opposite. Instead of looking for what is this angle measure based on these arcs, it's going to be finding the arc measure of this arc all the way across here based on the fact that we know an expression, excuse me, that's not very straight, for this angle. So angle x is 5 plus 9x. That means this arc, the pink arc I drew, traced right over here, that arc has to be twice as big as that. So that arc has to be 2 times 5 plus 9x. And again, I could go ahead and distribute the 2 right now, or I can leave it like that. But this arc, and I'm going to color code it, this arc, I'm going to make it yellow because it goes with this measure. And again, I now have measurements going all the way around the circle. I've got 9x plus 8, 14 plus 14x, and 2 times the quantity 5 plus 9x. So I can write an equation. And I'm going to do that, and my equation says 9x plus 8, I'm doing it in the same order I just said it, plus 14 plus 14x, plus 2 times the quantity 5 plus 9x, has to all, that's going all the way around the circle, so that has to all add up to 360. So now I would definitely distribute this. That's going to give me 18 x's. Add that to 14 x's. That is 32 x's. And add 9 more and we get 41 x's. Plus 2 times 5 gives me 10. Plus 14 is 24. Plus 8 is 32. Equals 360. And so on. So I'm trying to solve for x here. Next one. Okay, this one's pretty straightforward because the thing we want and the thing we have, excuse me, the two things that we have really is, I guess what I'm trying to say, are related directly. We know the relationship between these two. One is an angle that has its vertex on the circle, so that's an inscribed angle. The other is an arc that's intercepted by that angle. So we know that an inscribed angle is always half of the arc it intercepts. So I could either say this 6x plus 2 is half of 11x plus 11. So let me write that over here. 6x plus 2 is half, and I can't really write a fraction very well with this, so I'm going to call it 0.5, of 11x plus 11. I could do that, or instead of having to take half of 11 twice, in fact, I'm going to turn it around and say it the other way. Remember, if one thing is half the other thing, in other words, a smaller thing is half a bigger thing, then the bigger thing is actually 2 times the smaller thing. So that's how I'm going to write my equation. 11x plus 11 is 2 times 6x plus 2. So 11x plus 11 is 12x, I'm distributing, plus 4. And then I can go ahead and solve and find my x. And that's the last one I wanted to show you. So happy equation solving, happy equation setting up, and happy finding of inscribed angles and arcs.